All right, let's take a few minutes to do a drill. Let me describe that to you, and then I'm going to show you my solution. So on the course website is a file called temperature.csv. This file consists of two columns, year and temperature, corresponding to the change in global temperatures in Celsius relative to a baseline from 1880 to 2016. So we're going to, for every year, we are going to have a delta of temperature in Celsius. So I'm going, and this is real data, I'm going to ask you to read the CSV file, creating two lists. These can be NumPy arrays or lists, I don't care, consisting of the year and temperature. So read that CSV file and parse them into two lists. Please plot for me the change in temperature as a function of year and label all the axes and make the graph looks pretty. So you should have an X label, a Y label, and maybe a title. And one thing I will warn you about, that when you read from a CSV file, the data will come in as a string, not as a number. So where you need to convert these things to numbers, make sure you do that either before. I would argue that you should do it before you store it into the list, so that when you plot it, you actually have numbers, not strings. Okay, please take some time to do that, and I'm going to show you my solution in a second. Okay, I hope you got that solution. Let me go ahead and show you mine. So I'm, of course, put the temperature.csv file into my directory where the data is being run here. I'm going to open that up as a CSV file, and I'm going to read the data. So this is the same before, and I'm going to skip the header. Okay, so this we've seen before, just simply getting the data in, get rid of the header because that's not data. I certainly don't want that because I'm going to start shoving some data into a list. I'm going to initialize two empty lists. I chose to do this as lists. You could have done them as NumPy arrays as well. Now what do I need to do? So every file of the CSV data file is, every line rather of the CSV data file is a year and a temperature, year, temperature. So I'm going to read one line at a time. I'm going to extract that data and I'm going to shove them into the Y and the T arrays. So for row and CSV data, that will give me one row, two numbers, actually two strings. The 0th element is the year and the first element is the temperature. I'm going to convert this into an integer. It's a year, it's not a floating point. And I'm going to convert this into a float because it's a decimal value, not an integer. And I'm going to append them to the corresponding Y for year and T for temperature. And notice that I'm appending because I want to retain the order. So the first line will be in the first position, the last line of the file will be in the last position. And now I'm going to just go ahead and plot. So let me go ahead and evaluate this and we can see the plot. So I'm going to plot Y versus T. I've got an X label, a Y label, and I left off the title here, but you could have showed a title, and then I show it. And you can see here for the years from 1880 to 2020, we have a difference in temperature in Celsius, now almost approaching 1 degree Celsius. So this trend is obviously very strong starting in the mid-1900s, and this is, of course, the trend that has many climate scientists concerned about global climate change. I didn't ask you to do this, but let me just go ahead and show you one little bit of code that I wrote just for fun. I was curious, which is if I carry that data out, what happens? So what I've done here is I've taken that same data from before, that's in blue here, and I've extrapolated. I fit a function to that. I'll describe that in a second. And then I ask, okay, I have a function that describes this chunk of data. What happens if that trend continues? And you can see here that by the year 2100, even by the year 2050, things are not looking good for us. And so this is a way of making predictions from historical data. And I won't go through the details of this because you don't actually have all of the machinery for this. So this is the same code as from before. I simply read in the data. And this little bit of code here, the reason I like to do this is to sort of a precursor of what's to come. We are going to learn in the second half of this course what this does. What this is doing is building a linear model. In this case, it is a second-order polynomial that computes, that fits this data in blue here to a second-order polynomial. So that is, I'm asking, how does the temperature relate to the year as a function of the year squared plus the year plus a constant? That's a second-order polynomial. And this little bit of code here, again, I don't expect you to know it, but I do expect you to know it after a few weeks, is the types of data analytics that we're going to start learning immediately after this lecture. Okay, so That's it for the drill. I'll have all of this code and the data up on the course website, so you can go ahead and look at those solutions. And I have one more thing to do, which is how do we read and manipulate images in Python. So we're going to do that, and then we're going to get started on the second half of the course on data analytics.